Welcome to tonight's video on the chain rule. All right, so the chain rule is basically the power rule, but with a function inside of the power. So basically the way to look at it as well is that there is a function inside of a function. So let's take this, for example, 3x to the fourth minus 1 to the second power. Like before we even introduced the chain rule, to do this, there's a couple different ways. One way would be to FOIL this out first. So when you FOIL, you get y equals 9x to the 8th minus 6x to the 4th plus 1. And then you took the derivative of that, so you get 72x to the 7th minus 24x to the 3rd. All right, or you could do the product rule, right, where you said f of x would be 3x to the 4th minus 1, f prime would be 12x to the 3rd, g of x is also 3x to the 4th minus 1, and g prime is also 12x to the 3rd. And notice if you do f g prime, so 3x to the 4th minus 1 times 12x to the 3rd, plus 3x to the 4th minus 1 times 12x to the 3rd. If you add them together, well, first you got to multiply, but that gives you 36x to the 7th minus 12x to the 3rd plus 36x to the 7th minus 12x to the 3rd. Then you combine like terms, and you get 72x to the 7th minus 24x to the 3rd. Notice it is the same as what you got on the other one. So those are the two ways up until now we've had to do this. So the question it asks here is, why can you not apply the power rule? The power rule, basically, remember, you would take the power and multiply it by what's in front, and then subtract the power by 1. So basically the power rule would say you would do that. 2 times 3x to the 4th minus 1, which means it would be 6x to the 4th minus 2. Well, the reason why the power rule doesn't work and these other, like especially the product rule, works is because notice you factor in the derivative of this function that's inside the squared, right? And the derivative of inside the square is the 12x to the 3rd. So if we multiplied by that 12x to the 3rd and we distribute, notice now we get our answer of 72x to the 7th minus 24x to the 3rd. And that is where the chain rule comes in. So basically what it means here is that in order to apply the power rule, you must do the power rule times the derivative of the inner function. So this, what this is saying here is when you have the combination of two functions, when you have an inner function and an outer function, you take the derivative of the combination times the derivative of the inner function. So basically, if you have f prime of u, or sorry, if you have f of u equals u to the n, to take the derivative, you take n times u to the n minus 1 times the derivative of whatever u is. So we'll talk about how to substitute and all that stuff. So for example, here, notice the inner function is 7x to the third minus 5x plus 3. So what I'll do is I'll say let u equal 7x to the third minus 5x plus 3. That means g of u is equal to u to the 6th. So g prime of u would be 6u to the 5th times the derivative of whatever u is. So to find the derivative of x, you are going to take 6 times 7x to the third minus 5x plus 3 times the derivative of u. Well, u prime here is 21x squared minus 5. And there you go. That is the chain rule. That gives you the derivative. Sorry, it should be to the 5th power here. So basically all I did was I took what u was and I substituted in here, and what u prime was, and I substituted in there. Let's do another example. Here we have a radical. Remember, a radical is the same as raising something to the 1/2 power. So we'll let u equal x squared minus 4x plus 1. U prime is 2x minus 4. So basically, y equals u to the 1/2. Y prime is 1/2 u to the negative 1/2 times the derivative of u. So if we substitute in what the u is, so 1/2 x squared minus 4x plus 1 to the negative 1/2 times 2x minus 4. Now notice, first of all, what we can do here is 1/2 times 2x minus 4, because we can't multiply the 1/2 to the x squared minus 4x plus 1 because it's already being raised to a power. We would have to do that first. So this gives us that y prime is equal to x minus 2 times x squared minus 4x plus 1 to the negative 1/2. Well, if it's raised to the negative 1/2 power, it has to go to the bottom of the fraction to be a positive exponent. And so here is our derivative, right? X minus 2 over that quantity to the 1/2 power. So basically, remember, think of the chain rule as the power rule times the derivative of the function that's inside the parentheses. So here, another example, here's the chain rule with trig functions. So notice inside the parentheses here, we'll say u equals 3 pi theta minus 4. So u prime is equal to 3 pi, because theta is the variable. So s of u is equal to cosine u. So s prime of u would equal negative sine u times u prime. Well, s prime of theta, when I substitute in, is negative sine 3 pi theta minus 4 times 3 pi. Well, remember, you can't multiply these. If you're multiplying, this goes to the front, and it becomes sine s prime of theta equals negative 3 pi sine 3 pi theta minus 4. Final answer. All right, so let's do some more complex examples. All right. Actually, here's some examples of the chain rule. And then we'll get to some complex where you do chain rule and quotient or product rule in one problem. So first here, this is going to be your u, what's in the parentheses, so 3x squared minus 5x plus 7. U prime is 6x minus 5. So we'll say f of u equals 1/6 u to the 4th. So f prime of u is equal to, well, 4 times 1/6 is 2/3. U to the 3rd times u prime. So when we replace the u with the x, it's 2/3 times 3x squared minus 5x plus 7 to the 3rd power times 6x minus 5. So, if you notice here, 2/3 does not go in evenly to 6 and 5, so there's no real reason to distribute this. So the only thing left is to rewrite it. So it would be 2 times 3x squared minus 5x plus 7 to the 3rd power times 6x minus 5 all over 3. Right? 3 is the only thing at the bottom of the fraction. Here's one with a square root. So we'll let u equal 6x squared minus 1. U prime equals 12x. So this is 3 times the 5th root of that. So f of u is equal to 3 times u to the 1/5, because that's the 5th root. So f prime of u is equal to 3/5 u to the negative 4/5 times u prime. So now f prime of x, when I replace the u's with what they're equal to, is 3/5 6x squared minus 1 to the negative 4/5 times 12x. So now, moving stuff around, so notice this is a negative exponent, so it's going to move to the bottom of the fraction. So it's going to be 3 times 12x over 5 times 6x squared minus 1 to the 4/5 power. Well, 3 times 12x becomes 36x over 5 times 6x squared minus 1 to the 4/5 power. Final answer. All right, here's an example of having a chain rule and a product rule. All right, the first thing I would do, though, is any constant here, I would distribute this in there. So really, this is f of x equals 21x plus 14 times 4x squared minus 2x plus 1 to the 1/2 power. So your product rule here, one function, the first one is 21x plus 14. The derivative of that is just 21. The second function is 4x squared minus 2x plus 1 to the 1/2 power. This is where you would do the chain rule. That's g of x. G prime of x would be the chain rule. So remember, your u is 4x squared minus 2x plus 1. U prime is 8x minus 2. So here it would be 1/2 4x squared minus 2x plus 1 to the negative 1/2 power times the derivative, which is 8x minus 2. Notice half of 8x minus 2 gives you 4x minus 1 times 4x squared minus 2x plus 1 to the negative 1/2 power. That would be your derivative. So when you do the product rule to find the derivative of the overall function, remember the product rule, you just take f times g prime, so you have 21x plus 14 times 4x minus 1 times 4x squared minus 2x plus 1 to the negative 1/2 plus, and then you go f prime g, so you got plus 21 times 4x squared minus 2x plus 1 to the 1/2 power. Now notice there is a common factor here in both terms, that is 4x squared minus 2x plus 1 to a power. When you factor it out, you always take out the smallest exponent. So you're going to take out 4x squared minus 2x plus 1 to the negative 1/2 power. And then what's left is you have 21x plus 14 times 4x minus 1 here, because you took out this. And then on the other side, you have plus 21. And then remember, when you take out something to the negative 1/2 power, remember it's like dividing. And remember, you subtract the exponents of 1/2 minus the negative 1/2 means you have 4x squared minus 2x plus 1 to the first power. So what that means is that now you can multiply this stuff out. So you have what you factored out. And then in the brackets here, first we can FOIL. So we would get 84x squared, 21 times, so minus 21 and 14 times 4 is 56, so plus 35x, and then minus 14. And then here when you distribute the 21, you'd get plus 84x squared, minus 42x plus 21. And then when you simplify, we would get 168x squared minus 7x, and then plus 7. So therefore, then here you have a negative exponent, so that moves to the bottom of the fraction. So you have 168x squared minus 7x plus 7 all over 4x squared minus 2x plus 1 to the 1/2 power. That is your derivative. So that is an example of the chain rule within the product rule. So here, the next one, it says find the derivative. Get rid of that. It says find the derivative of this quotient, right? So this quotient to the 4th power. So notice the u here is 3x squared minus 2x plus 1 over 5 minus 7x. So this is f of u equals u to the 4th. And then f prime of u would be 4u to the 3rd times u prime. Well, to find u prime here, we do the quotient rule. So f of x would equal 3x squared minus 2x plus 1. F prime of x would equal 6x minus 2. The denominator g of x is 5 minus 7x. And then g prime would be negative 7. So remember, to get u prime here, we would do g times f prime, so 5 minus 7x times 6x minus 2 minus negative 7 times 3x squared minus 2x plus 1 all over 5 minus 7x to the second power. Now, we could simplify this a little bit. So we would get, so here when we multiply, we would get 30x, actually, sorry, I'm going to FOIL this kind of in my head. I'm going to go negative 42x squared. So it's going to be 14x and 30x, so plus 44x, and then minus 10. Here you can make it plus plus, so when you distribute you get plus 21x squared minus 14x plus 7 all over 5 minus 7x squared. When you combine like terms, you get negative 21x squared plus 30x minus 3 all over 5 minus 7x squared. So that's your derivative. So when you do f prime of x here, you get 4 times 3x squared minus 2x plus 1 over 5 minus 7x to the fourth power times the derivative, which is negative 21 negative 21x squared plus 30x minus 3 all over 5 minus 7x squared, like that, quantity. Now, here, since we have a fraction, right, this you can take it as 3x squared minus 2x plus 1 to the fourth over 5 minus 7x to the fourth, right? If it's being raised to the fourth power as a fraction, that means each one is. And the reason why I would do that is because now, notice you have the same term on the denominator. So I would get 4 times 3x squared minus 2x. Actually, you could multiply this 4 in, so you would get negative 84x squared plus 120x minus 12 times 3x squared minus 2x plus 1 to the fourth, all over 5 minus 7x to the sixth, and that is your derivative. So that's an example of a quotient rule within the chain rule. Yes. All right, last one here. So here we have a quotient rule, right? So we have two functions. We have f of x equals x to the third plus 4 to the fifth power. And we have g of x equals 1 minus 2x squared to the third power. So to take the derivative of each one, we have to do the chain rule. So this means the derivative here would be 5 times x to the third plus 4 to the fourth power times the derivative of what's inside, which is 3x squared. So basically you would have 15x squared times x to the third plus 4 to the fourth power. For the derivative of g, it would be 3 times 1 minus 2x squared squared times the derivative of what's inside, which would be negative 4x. So this would be negative 12x times 1 minus 2x squared squared. So when you do the quotient rule, remember, it is gf prime, so it is 1 minus 2x squared to the third times 15x squared times x to the third plus 4 to the fourth minus, and then we do the other, so it's x to the third plus 4 to the fifth times negative 12x times 1 minus 2x squared squared, and that is all over g squared, so it's 1 minus 2x squared to the third squared. So now we could factor out common factors, like for example in the numerator both terms have a 1 minus 2x squared. Both terms have an x to the third plus 4. And both terms have an x, right? And they have a factor of 3. So we'll factor out what they have in common first. So here they have in common a 3x, and then 1 minus 2x squared to the power of 2. And they also share x to the third plus 4 to the power of 4. So that's what we're going to factor out. When we raise the power to the power here, that gives us to the sixth power of 1 minus 2x squared to the sixth. Here, what's left? Well, when you take out the 1 minus, so first of all here, you take out 3x, so you're left with 5x. And then you have 1 minus 2x squared. And then you took out everything there. And then here, you're left with a negative 4. And then you took this out, and you're left with x to the third plus 4 there. So now, we still have what we took out, 3x times 1 minus 2x squared squared times x to the third plus 4 to the fourth. And then here, when you distribute, you have 5x minus 10x to the third. And then this becomes plus plus. So plus 4x to the third plus 16. So in the parentheses here, you have negative 6x to the third plus 5x plus 16, and that's over 1 minus 2x squared to the sixth. Notice here, these are both the same, and one's the second, one's the sixth. So basically, it's going to move to the bottom and only have the fourth power. So you have 3x times x to the third plus 4 times negative 6x to the third plus 5x plus 16, all over 1 minus 2x squared to the fourth power. And that is your final answer for the derivative. All right, I hope you enjoyed the video on the chain rule. And if you have any questions about anything with that, please come in and we'll go over it. Have a good rest of your evening.